Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. This is a problem on sequences in arithmetic progression, and we are given a sequence a1, a2, ... an that is in arithmetic progression, and then we are asked to find the value of these sum, which is really the sum of the reciprocal of the products of consecutive terms taken two at a time. So 1 by a1 multiplied by a2 plus 1 by a2 multiplied by a3 and so on till 1 by an minus 1 multiplied by an. And it's given that a1, a2, a3 up to an, these are terms of an arithmetic progression. So they're consecutive terms of an arithmetic progression. And we have a multiple choice question here. So we're given 5 options and we have to pick the right answer. So before we start this problem, it's good to basically write down the two fundamental conditions or equations when it comes to the terms of an arithmetic progression. Well, the first condition is very basic. That's what defines an arithmetic progression, and that is the difference of successive terms must be the same. And that's usually called the common difference of the arithmetic progression. And I'm denoting that common difference by D. The other thing that's important for this particular problem and more generally for any problem with arithmetic progression is how we write the nth term in terms of the first term. And that can be shown to be an is equal to a1 plus n minus 1 multiplied by d, where an is, of course, the nth term of the progression and a1 is the first term and d is the common difference. So these two are important conditions or important equations that apply to a sequence that is in arithmetic progression. That's always worth remembering and really comes in handy for many problems related to arithmetic progression. So now we can start solving the problem. So we are given this sum of reciprocals of products of consecutive terms of the progression taken two at a time, and this by itself is not an arithmetic progression. So we cannot treat this like an arithmetic progression and sum it, right? So we need to do something with this one. And one of the tricks for this particular problem is, I can basically write out the numerator because I have, these product of consecutive terms in the denominator. I can potentially, somewhat simplify the situation by writing the difference of successive terms in the numerator, like a2 minus a1 divided by a1 a2 plus a3 minus a2 divided by a2 a3 and so on. And then for maintaining parity, I have to basically divide the whole expression by d, because a2 minus a1 is equal to a3 minus a2 is equal to an minus 1 is equal to d. And that's what we wrote down the very first line of the problem. That's what defines the arithmetic progression, right? So in order to maintain parity, I have to basically divide the whole thing by 1 by d, or rather by d. So I've basically taken out 1 by d as common, and then within the parenthesis, I could basically write out each numerator as the difference of successive terms. And once I do that, I can potentially simplify this, or rather like expand the terms out like this. So the first term becomes 1 by a1 minus 1 by a2. The second term becomes 1 by a2 minus 1 by a3, and so on. And one of the things we note here is, the terms get cancelled out. So all the intermediate terms like minus 1 by a2 will basically get cancelled out by plus 1 by a2. Similarly, minus 1 by a3 is going to cancel out by plus 1 by a3. And so all the interim terms of the progression of the sequence, they will basically get cancelled out. The reciprocal of those terms, like 1 by a2, minus 1 by a2 plus 1 by a2, minus 1 by a3 plus 1 by a3, and so on, right? And what we'll be left with is simply the reciprocal of the first term, and then the negative of the reciprocal of the last term. So 1 by a1 minus 1 by an. And once we have this, we can basically further write this as 1 by d multiplied by an minus a1 divided by a1 multiplied by an in the denominator. And now we basically refer back to this term, to this equation in circle, right, which states the relationship between the first term a1 and the nth term an. And from this relationship, we can easily note that the difference between an and a1 is simply n minus 1 multiplied by d. And that's what we have in the numerator in this particular expression, right? So we can substitute the numerator by n minus 1 multiplied by d. And then d and d gets cancelled out from numerator and denominator, right? And we're simply left with n minus 1 divided by a1 multiplied by an. And then going to the list of options that we're given, the correct choice will be the option D, n minus 1 divided by a1 multiplied by an.